Let's make sure you got it. You know the unit circle, right?
Unfortunately.
Fortunately.
At the same time.
Fortunately, you know it.
Still don't know if you, I just don't do too much.
Okay. What's the radius of the unit circle?
1.
Okay. And if I have coordinates of root 3 over 2 and 1/2, what is the measurement of that angle? In radians?
30? No, 60.
That's degrees. Radians, sir.
Well, I was right at 30.
Okay.
Right over 30. Or no,
Power 6.
5 or 6.
Gotcha.
Okay. Do you know that, say the cosine at pi over 6 is,
Root 2 over 2.
and the sine is? Right, because the y is 1/2, that's sine, and the x is cosine, right? Okay, this directly relates to polar coordinates. Right? X, y, the polar coordinate is r theta. Remember that? So what's the radius?
1.
1, and the theta is
So is
5 or 6. See how all
the
that
radius
relates?
always 1 though? Isn't the radius always 1?
In a unit circle,
Yeah.
but we have polar coordinates, and we're going to expand that to having different radii.
So could
Okay.
you have a radius of like 1/2 and then pi over 6, so it'd just be a little bit closer
Yeah,
in?
but you have different x, y coordinates,
Right.
right? Because the radius is different.
Yeah.
So those directly relate to each other. Okay. So its polar coordinate is an r and a theta. Okay.
So is theta always that angle?
Uh-huh.
So theta can remain constant, and if you change the radius, it'll change your x, y accordingly?
We'll change where the point is located. Yeah. Yeah, like you were saying, we could do this point, which might be 1/2 radius pi over 6 angle. Okay. Or you can change the angle. Where would I plot? One pi over 2.
0.1?
Okay. What would this be?
Good.
0.1?
Good, right there. You go to pi over 2, and then the -1 is the radius. So you actually go the opposite direction. That makes sense. So a negative radius. So positive would be just straight up, but negative would be the opposite side of that. Okay. So these all have equivalent angle measures. Like I could write this one as -1, 3 pi over 2. Because you go 3 pi over 2, -1. Okay. I could also write it 1 negative pi over 2. So I have negative pi over 2, -1. Right. What's the other way I could write that? If there is one.
Don't you have one?
You do
Because 1 negative pi over 2 would be
negative 3 pi over 2?
That's the way it is.
And if you want
1.
So each polar coordinate actually has 4 different ways you can write it. Pretty interesting, isn't it? Isaac thinks it's ridiculous, I think it's
You
interesting.
thought finding slope was hard.
Okay.
1 point.
All right, so, get the idea. How would I change from polar to rectangular?
Put R in terms of X.
So we want to get x equals and y equals, right? Yeah. Because we want the rectangular coordinates. So if you're looking at the unit circle, what is the x based on? What function?
Sine. No, cosine.
Cosine, right? So the formula x equals r cosine theta, and the y would be r sine theta. And then similarly, rectangular, polar. Polar? I don't think polar coordinates are something that exists. Polar. We want r and theta, right?
Would it be x over cosine theta or
No,
no?
the theta can't be there. So look at this triangle. What kind of triangle is it? Yeah, what type?
Right.
It's a right triangle. If you have x and y in a right triangle, how can you figure out r?
Oh,
Right over on.
Pythagorean theorem. So the radius is the square root of x squared plus y squared. Right? Pythagorean theorem. And how would you calculate the angle measure based on x and y with trigonometry?
which angle?
It's opposite and adjacent, right? So cosine.
No.
No,
No, you have
sine.
opposite,
Sine.
adjacent. No, you're on the beach, you get a
Tangent?
Oh,
tangent.
trigonometry. Someone will hippie, cut another hippie.
Trigonometry.
Oh,
T-O-A. TOA.
There's no slope itself.
That works too. Okay, so tan theta equals y over x. Right. Do you want me to run through an example?
Yes, presumably.
Sure.
So, how about we have 3 and 5 pi over 6. Convert to rectangular coordinates.
5 pi over 6.
Yep. Check me if I'm wrong.
Five pi over 6 is 270? No.
150.
Yeah. I don't know why I said 270.
I believe those are correct. Hold on a sec. No, those are backwards. That was dumb. Dum, 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 dum.
And wouldn't your x be negative?
There we go. Now it's right. So we get negative 3 over 2. And 3. Okay. Good that? just have to know your unit circle or have a calculator, right? How about that coordinate in polars?
Unit circle.
R is
root 13.
Root 13.
Then, 230.
No, 10 equals 2/3, so arc 10 at 2/3.
yeah. That's a calculator question. Make sure you're in radians mode.
Do we ever use degrees in calc?
No. Radians are your real number measurement for an angle. Degrees are not. Anybody know what tan inverse 2/3 is?
But he framed us.
I don't. Calculator she does. Good. 3, 2, 1.
Wait, what?
3, 2, 1.
Okay, there you go. Keeping in mind that is not XY, that's R and theta. Anybody know what .321 radians is?
Sadness.
Can you guess something very common?
Multiply by 180 divided by pi. Remember that.
Do it.
What do you agree?
18.42.
How many?
18.434.
That's close. So, any questions on plotting polars or exchanging rectangular to polars? Really good. Okay. I think we're good. Next. Line through the origin.
Isn't that just radius? No, that's not.
Does a line have a radius?
No.
No. Okay, so is R going to be involved in this in any way?
No.
It's not. Okay. Star that. R is not involved. There's a line has no radius. Okay. So what are we going to base this off of?
Angle.
The angle. So what would your equation be?
What did you
Say the angle's power 4. What would the equation of the line be?
No.
Y1
No.
no.
Polar. You're making it way harder than it needs to be.
Arc and the pi equals.
Remember, polars are a radius and an angle, right? Do we have to worry about radius?
No.
No.
Okay, so the angle is
Pi equals.
line through the origin. Okay, so there's your equation for a line through the origin. It's just the angle. Okay.
So
Just
will
the
it
angle.
give us like trick questions or say the graph makes this triangle, these angles are
It could say
theta.
a line goes through the point 2, 4. What's the equation in polars?
And do you assume that it's the origin too?
Yeah, we would say oppositely.
Would be the square root of 4 plus 2.
How do you get the angle?
Oh no, it'd be 2 squared plus 4 squared.
No, that's R.
So,
Yeah, so we have tan theta
Go.
equals 4/2. What's the tan inverse of 2?
$1.107.
Okay. All right. Last slide. We are going to sketch a graph. This is what's called the Lemas-Combe curve.
I read that as lima.com.
Lemas-Combe. It's a C with a little squiggle under it. It's a lot easier to read in the book. Okay. But it's pronounced Lemas-Combe. So we're just going to plot it point by point.
Okay.
Okay, so use your unit circle. If theta is 0.
1.
Pi over 6. Well, let's go with pi over 4 and try that. Root 2 minus 1. Correct?
Yeah.
So 0.414 about pi over 2. Negative 1.
Yeah.
And then 3 pi over 4.
Negative 2 minus 1, right?
Negative root 2 minus 1.
Yeah.
And pi.
1.
Negative 3.
What? Yeah.
Oh,
Cosine.
yeah.
Let's start there. You don't have a grid, so I'm just going to have to sketch this in my hand. Unfortunately. Okay. 0, 1. Power 4. 4, 1, 4. Power 2, negative 1. Pi over 4.
So when you, never mind. This is another question. No, it's not. Pi equals 3. That's where I would go.
What on earth is going on here?
I don't know.
This is just a cosine graph.
Okay, so that first dot right
No.
there on the line is
Huh?
1, correct?
So notice order matters here. We went like this.
Oh, Oh.
I told you.
Oh, it's like the seashell thing.
Yeah, so this curve follows,
Oh,
Looks like
the
the.
seashell
what's it
thing.
called?
Oh, is that the one where you find it like everywhere in nature?
Pyramid.
no, actually it is not.
Oh,
Okay,
when was
now,
the
we've only done 0 to pi. All polars come back on themselves and repeat. So we need to finish this. Okay, so, but here's what's nice about a lot of polars is they're symmetric about in some way, shape, or form. So if we went and finished 2 pi, this would have the same coordinates, except it would be symmetric around the x-axis.
Yeah, that's cool.
Yeah. Pretty weird, huh? So part of the challenge with polars is determining your intervals to graph. Okay. So 0 to 2 pi works here. But sometimes 0 to pi does the whole entire thing. Okay. And we will talk about that with areas where it really comes into play.
What's the farthest you have to go?
Usually 2 pi units in some way, shape, or form. Yeah, there are, so some of the neat graphs with polars, you can have circles, of course, in polar coordinates are really easy. But you can do, like, there are graphs that look like this.
Oh, it's that thing.
Right.
That thing looks like it's going out the
You
window.
can have graphs.
Could you grab a tesseract with polars?
The cardioid looks like a heart. There's all sorts of neat stuff you can do with polars. They're very fluid and very smooth. Any questions? Good. Something to work on.
All right, homework. See you tomorrow?
Yep.
Well, now I need to watch that.
What?
Seven Brides for Seven Mothers. It's a good one, huh?
Classic musical. Saw a pretty good one on Thursday of last week. That was fun.
I'm glad you enjoyed it.
We're so glad to not enjoy Thursday's show.
Why?
Friday was our best.
So I heard. There were a couple slip-ups, but
Let's just say Saturday, some of the actors took a little bit too much freedom.
improv?
Uh-huh.
Wow, why?
I don't know.
Follow the line.
Because they got excited with everyone cheering for them.